right, this is it. This is the last talk of Forward CloudSec. Thank you for staying with us to the end. Immediately following this, we'll have 2 birds of a feather sessions. I will help organize folks on a discussion on how to make feature requests heard at your cloud provider. Chris, who is wearing a jacket over there, will be leading a discussion on how we actually use AWS organizations in the real world, regardless of what best practices may be in light of M&A and various other things that happen in the real world. But right now we have our final talk, which is Standardizing Terraform Linting, how Square detects and prevents cloud misconfigurations. So please welcome Adam.
Hey everyone, welcome. Thanks for coming. So today I'm going to talk to you about standardizing Terraform linting, and specifically an overview about how we at Square have done and are doing this shift left, and how we're integrating Terraform linting into our workflows. So just a quick note on who I am. My name is Adam. I work for the infrastructure security team at Square, and I'm specifically focusing on proactive cloud security. So let's get right into it. So given the broad scope and rapid innovation of cloud platforms, misconfigs are inevitable. So this has been a growing sentiment these past few years, and you've probably seen one of the many public security incidents stemming from some simple misconfigured cloud resource. So the Capital One breach is a pretty high profile example of this. And so at Square, we're trying to catch these misconfigured resources before they ever turn into something more serious, like these examples here. So here at Square, we like to give engineers the flexibility and autonomy to develop on the cloud. And conversely, this means that they could very easily make changes to their cloud accounts that may impact the security of their service without any guidance, expertise, or knowledge that they're doing a bad thing. And one of the ways we're trying to bootstrap and scale the cloud security team's guidance, expertise, and knowledge is with runtime misconfig detection and alerting. And so we have a system that aggregates, enriches, and attributes runtime cloud misconfig to the appropriate owner. And just as a note, this talk is not about this misconfig alerting system, but we'll use it as a case study on what we can improve. So what you see here is a redacted part of a real Square misconfig that was sent out to an engineer. Let's take a closer look. So this is an alert for an EC2 instance that has a public IP address. And do you notice anything interesting here? So this system was able to catch the misconfig shortly after it was deployed to the cloud. A few things went wrong here though. So the change was initially attributed to the wrong engineer, employee Y. And while employee Y and employee X are both part of the same team and both technically owners of the account, employee X was the person who actually made the change that triggered the misconfig. So now employee X is aware of the misconfig a day later, but explains that they weren't aware of the full extent of their change when they were making it. And after employee X's initial response, a fix wasn't issued for 10 months. So what can we take away from this? So this ticket shows inherent friction to many people. So the engineer who was initially tagged that had nothing to do with the change, the actual engineer who made the change, and us as security engineers to chase down a fix. And it's clear we didn't do a great job given the 10-month gap, but that's besides the point. So just because a misconfig was detected quickly, it doesn't mean it'll be acknowledged or fixed quickly. So the infrastructure is already up and running and Square was being exposed to unnecessary risk. The second thing is people are flooded with Jira alerts, email alerts, Slack alerts, and they routinely ignore them as unimportant. And really you can't blame them. So we need to alert as close to the source as possible. Alerts on different platforms, days, weeks, or even minutes after performing an action can get lost. So even if a misconfig is acknowledged by the owning team, it may not be the right person with the right context, and granularity matters here. And the last thing is firefighting isn't fun for anyone. So chasing tickets, whether this is us as security engineers, platform teams, or service owners, is expensive. It's just inherent friction for everyone. So now that we've seen the friction with runtime alerting, how do we reduce this friction and catch these issues before they happen? So the new hot phrase seems to be shift left. And here at Square, we've hooked heavily into infrastructure as code. So it gives us a centralized, scalable place to bootstrap any safe defaults, any guardrails, any detections into our infrastructure. But more importantly, it just makes it quicker, safer, and easier for engineers to build services aligned with best practices. And so shifting left has been talked about in previous blog posts and presentations. So we'll focus on how we've done this at Square. But before I do that, I want to give a quick primer on how the account vending process works at Square. So as an engineer can create an app, and it's generally how we refer to the overall service. And the infrastructure for their app can be in the data centers, which is where we started, or in AWS or GCP, where we're migrating to. And we like to give engineers the freedom to experiment and use whatever tool is easiest for the job, whether this is AWS or GCP. And so autonomy and flexibility are the names of the game here. And now, say I'm an engineer, I want info for my app. I can essentially self-service request an AWS or GCP account for my app through our account vending service. This account is then provisioned into our org, which sets up all of the standard runtime security tooling. So think about the misconfig alerting system I just spoke about. And then more importantly, for the context of this talk, each new app using one of the clouds will be bootstrapped with some standardized Terraform repo and corresponding CI pipeline. So more about how we bootstrap Terraform at Square. So we give engineers a few things. We give them a Terraform repo that's auto-created in our GitHub org with some starter Terraform for you that sets up any like Terraform backend and providers correctly. We also drop a binary on their laptops called SQTF, and this is just a thin wrapper around Terraform, making it easier to work with Terraform at Square. And finally, when an engineer opens a PR against their main branch, a build and CI is kicked off that runs a Terraform plan, and it'll comment the proposed changes back to the pull request. So any PR reviewers can see exactly what changes would be applied from this PR. So how do we introduce usable security controls into this workflow and incorporate any lessons learned from the runtime misconfig alerting? Terraform linting, obviously. So we built SQTF lint, which is just our Square thin wrapper around the open source infra as code static analysis tool checkoff. And this just stands for Square Terraform Linter, nothing fancy, hopefully self-explanatory. And so when creating and deploying SQTF lint, these are some of the things we were trying to accomplish. So for one, misconfigured resources should never become real resources. They should be detected and prevented before the infra is actually spun up. And two, we want to make this usable by giving engineers as real-time feedback as possible into their changes, the security impact of their changes, and any remediation info. And ultimately, we want to reduce the overall friction of shipping secure services. The engineers, they should spend less time dealing with infrastructure and security issues and more time focusing on feature and application dev. So now that we have a tool that can scan for security issues, we can introduce this tool into our Terraform workflow. So now, any change that uses our pipelines and workflow is automatically scanned for any security misconfig we define. So how do we actually integrate SQTF lint and Terraform linting into our workflow? We have a few options on where we could scan and what we could scan. But before we decide, I want to talk about some problems and some workarounds we ran into with these options. So the first problem is that HCL scans are short-sighted and they lack the full picture of the resources being spun up. So for those who don't know, HCL stands for HashiCorp Configuration Language, just a fancy way to say Terraform code. So HCL scans only know about the resource pre-variable processing, pre-interpolation, and pre-whatever else processing needs to happen. So this just means the scans might not pick up on all the potential issues. All right, so why don't we just use plan scans? Well, plan scans have their own problems. The first being that plan scans lack the appropriate context. So what do I mean by that? Here's an example of two scans, one HCL scan, one plan scan. If you're an engineer, what is easier for you to understand? And as you can see, the HCL scan on the right has some additional information about the resource tied back to the code. You can see there's a file name, some line numbers, and a blurb of the actual code creating the resource. You can easily look into these results and understand exactly what and where something went wrong. And this leads into problem number 3. So without any context of the underlying HCL code, rule suppressions couldn't be honored by plan scans. And essentially what this means is that plan scans can have false positives. So how did we handle this? We ultimately built functionality to enrich the plan scan reports with the underlying context of the code. And this actually means suppressions will be honored. And this was originally work we bootstrapped as part of the Square-specific SQTF lint, which we then later upstreamed directly to checkoff. So this is just an example of a plan scan with additional context. As you can see, the plan scan now has the code block of what's actually creating the resource, and suppressions are now being honored. So you can see there's a repo root for enrichment flag that can be set, and that just allows you to pass the location of the underlying Terraform code. So plan scans seem great now, right? Why don't we just use them? Well, auto-generating a plan file to lint every time the user makes a local change would add way too much friction into the development process. So HCL scanning versus plan scanning time is negligible, but actually generating a plan file for the plan file scan takes a non-trivial amount of time. So engineers want to move fast, and forcing plan file generation every time they make a change is way too costly to make it worthwhile. So now, knowing what we know, back to the original questions: where should we scan and what should we scan? And the answer is yes. Scan everywhere and scan everything. So first, we could scan the directory of the HCL on every commit. And this provides incremental security value without getting in the developer's way. This is fast, and it just creates a short feedback loop. And next, we'll generate and scan the plan file in CI when a PR is opened against the main branch. We get the most security value here just by virtue of having the full picture of what's being changed or added. And finally, just a note on reproducibility: there may be a delta between the HCL scan findings locally and the plan scan findings in CI. This is mainly just because HCL scans could give false negatives. So in the event there's a finding in CI that a user wants to reproduce locally, they can. We basically just expose functionality to them on their developer laptop built into SQTF that can plan and lint in one step. So now from an engineer point of view, this is our standardized Terraform workflow and user experience. So assuming this is after a cloud account is requested and provisioned, a user can clone their repo, make changes, test these changes, and when they're ready, they commit their changes, which then triggers a pre-commit hook that auto-lints their code. And this just returns the results near instantly in their terminal. If they want to continue developing, they can repeat this process and go back to step 2. But let's just say they're ready to create a PR. They do it, and it triggers a build that generates a plan file and runs a lint against that plan file. And after running, it'll output the results, the plan and lint results and remediation info directly to the PR. So now they have the full context of their changes, and they can fix whatever issues arise in near real time. So let's take a look at this pre-commit process from the user perspective. So on the left, you have a blurb of Terraform code, and it's creating a bucket called nuclear launch codes with some less than ideal configuration. On the right, they add and commit the file, and they're instantly met with, hey, here's some issues with your Terraform resources. Here's a Square specific guide to fix these issues. And so as you can see, they're getting dinged for the public read-write ACL and the lack of encryption at rest for this bucket, amongst other things. So the user clicks on this guide. It brings them to an internal wiki for that specific finding. And so this example on the screen has a description of the problem and a Terraform blurb that they can copy, which fixes the issue. All right, let's fix this issue. So they copy and paste this blurb into their code. And as you see on the left, we've added the fix to support server-side encryption, and we changed the ACL to public read from public read write. They re-add this, commit it, and boom. The encryption issue is solved, the public write issue is solved before the infra has ever existed. So now let's say they're ready to create a PR. As you can see, it kicks off some builds at the bottom. And what this is doing is it's generating a plan file and linting that plan file for each region and environment it'll be deployed to. And so it outputs these results to the PR. So this is an example of what changes are being made directly from the plan file generation. So as you can see here, you see the S3 bucket is going to be created with these configuration options. And these are the lint results with the corresponding remediation guides linked. So this tells you the security impact of those changes you're about to make. As you can see, there's still the public read, which we didn't remove. So now that we've discussed how we've integrated linting into our workflows, I want to talk about approaches to enforcement. So this system is deployed in complaint mode only right now, and we have some long-term plans to turn on enforcement on a per rule basis. So deploying in complaint mode only has allowed us to gather any useful feedback on our remediations or rules, and just kind of the overall general user experience. And by enforcement, what I mean is that a PR cannot be merged until the lint results are either fixed or suppressed. And there's a few things that could help us towards this enforcement goal. So first, we want to start with high signal, low noise checks. We don't want to burden engineers with any low or informational findings. Our theory is that if we're bothering them with our tool, we have to make it worthwhile. So the second thing is we'll make use of a recent checkoff addition, so the hard fail, soft fail mode. And that just enables us to turn certain findings on in complain mode and others in block mode. And onto an important UX feature, users should have the ability to self-service suppress any findings they deem intentional. And while we assume good intent, trust but verify is important here. So we need to make it as easy as possible to track and surface these suppressions. And this leads into my next point. Collect metrics. Collect metrics on everything. Suppression metrics, rule metrics, operation metrics, whatever else you want to collect. And not only does this help with tracking suppressions, but we could use these to tune and deploy only the essential rules. These could be used for things like turning rules from soft fail to hard fail, or to point out any systemic problem where a Terraform module will be better served. And I'll expand upon that point in a future slide. But finally, we want to make it as easy as possible for users to remediate. So our theory is that the effectiveness of this system is directly related to how easy it is to fix an issue surface. If it's too difficult or causes too much friction, then the system really isn't effective. So I want to expand on that last point and answer the question, how do we better surface findings and remediations? So in the first iteration of SKTF lint, we posted a general comment directly on the PR itself. So this would happen for each region and environment that a change was being made in. And at a quick glance, it was a fair bit challenging to process all this information. So often lint results would be posted multiple times for each region and environment, but the results were typically the same since they were usually tied back to the same resource. So now in its current state, plans happen the same way, but for lints, we'll do a resource lookup that'll comment directly on the resource itself. So if you look into the diff for the PR, it really highlights how effective and pointed this is. Each resource, as you can see here, the S3 bucket, only has its own findings attached to it and nothing more. So the best option is what we're working towards. We want to make it as easy as possible for an engineer to one-click accept a change right from GitHub. So they won't have to do any local development or view any guide. We can just auto-suggest a change that includes the now secure Terraform, and they can easily just one-click commit this change. So in this example, we recommend, hey, here's this server-side encryption configuration. If you click commit suggestion, your code will now be secure. So a quick note on Terraform modules. Modules are a great thing to give users since it handles most of the heavy lifting for them. And we could use Terraform modules to fix any systemic issues or deal with common use cases. And if we're collecting the appropriate metrics, we could determine what is systemic or not. And so the picture on this slide is an example of a remediation guide for an S3 bucket with a public read ACL. If this public bucket was intentional to serve static content, we point the user to a Terraform module that we set up that essentially will set up the S3 bucket with CloudFront to safely serve static assets. So if they use this module, we're able to auto-suppress this check internally, and they'll never hear about a public read ACL on that bucket ever again. So the last thing I want to highlight here is custom checks. And custom checks are a great feature built into Checkoff. And at Square, we expose these checks to the end users, so they could write whatever custom checks they want. It doesn't have to be security related. So if a team has any specific coding convention, if they want resources named a certain way, if they require specific tags, they could check these custom checks alongside their code, and they'll be honored locally and in CI. So now that we've been running the system for a few months and are actively collecting feedback and tuning rules, I just want to highlight some success stories. And so, as you can see here, people are deploying fixes caught by SKTF in a reasonable amount of time, whether this is fixing IMDSV1, enabling key rotation, enabling the appropriate encryption for resources, removing public resources. We've been seeing a lot of value here. And finally, I just want to end this talk with some general lessons learned. So for one, doing things the right way is hard. Developers need to keep up with the fast-moving broad scope of cloud. Terraform has its own set of knowledge requirements and issues. And throughout all of this, they need to think about security. So doing the right thing and expecting them to have all this knowledge is extremely challenging. And the second point, we need to combat this by giving them the usable tools, systems, and guidance to do the above without expecting them to be experts on it all. And this leads to my last point, which is no one is effective when too much friction is added. We want to let the developers focus on things that are important to them, and everyone can live happily ever after. All right, thank you.
The one thing I want to follow up on in your talk was the use of metrics, because that's something that we haven't, I think, heard a lot of over the past couple days. And it seems like a really great way to prioritize what you want to respond to and what developers are going to need. So can you say a little bit more about how you set up metric collection in your linter, and where these metrics go and what you're looking for?
Yeah, I mean, so this is currently a work in progress, the metrics piece. But the way we're thinking about it is if you are suppressing a rule, that rule suppression should be surfaced. Let's say that's pushed to SignalFX, and then that somehow there's a system that services that to the end user. So we actually have a web app that you could see the status of your service. So in that, we have a security tab, and in the security tab, it tells you security issues for your service. In that, we are thinking about saying, hey, you've suppressed this metric, we're just letting you know. And then as we move toward the future of Cloud at Square, this is something that could be used towards like a risk score. Like, you suppressed this metric, but it didn't really seem legit, so we're gonna ding you on our risk score.
Makes sense. Cool, and there are other tools that do commenting like this. So I'm familiar with Atlantis. I think there are a couple others out there. What led you guys to write sort of your own Terraform linting and apply harnesses as opposed to starting with a pre-existing tool?
Yeah, so I'm not really an expert on the plan portion of it. That was set up by our sister team, our cloud infrastructure team. But I think the general reason was that either Atlantis wasn't ready, or just we could set up our pipelines better or more efficiently or cheaper. I don't actually know the decision right now why that was made. In terms of like why we built SQTF lint and didn't pay for something, it just so happened we started thinking about this at the end of last year, and obviously budget comes into play, and that's just the reason.
That is a realistic reason. Any other questions? Oh, okay. Can I just give you the microphone?
The question is, how do you handle updated baselines? So how do you get your devs to redo their code or rerun it when you've updated the modules that they're based on?
Yeah, I know that Chekhov has a very new and neat feature that actually helps you define baselines. So we haven't hooked into that yet, but we will. If I had a link to that PR, I would send it, but take a look at that. Chekhov is really helpful there.
All right. Thank you very much, Adam.